Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Today's video, we are in TryHackMe SOC Level 1 Learning Path. This is the Network Security and Traffic Analysis module. This is the TShark, the basics room. Learn the basics of TShark and take your protocol and PCAP analysis skills a step further. Now, if you've been following along with this particular learning path, you can see that we've gone through Wireshark. So basically, TShark is like the CLI version or the command line interface version of Wireshark. And we're about to get down deep into the weeds a little bit to cover some things, and hopefully this can be another tool you can add to your tool belt. All right, so this is some things we're going to be covering: TShark and supplemental CLI tools, main parameters 1, 2, capture conditions, packet filtering options, capture versus display filters, packet filtering options, capture filters, and then display filters. And then we're going to wrap it up with the conclusion, summary, and then just go over briefly what we already covered in this room. So without further ado, let's go ahead and dive into it. As I was saying earlier, TShark is basically the CLI version or command line version of Wireshark, created by Wireshark developers. So it has most of the features of Wireshark. And it says that, however, it can also be used like TCP dump, therefore it is preferred for comprehensive packet assessment. So it sounds like it can do just about what everything Wireshark can do plus some. So Wireshark on steroids kind of is what I'm reading here. Learning objectives: filtering the traffic with TShark, implementing Wireshark filters in TShark, expanding and automating packet filtering with TShark. Awesome. So once again, there's the VM. Hit that green start button to start it. Here's some rooms to complete beforehand. It says network fundamentals and Wireshark modules. Before starting this room, check out my channel for videos related to that information. Task number 2, and let's see what they're talking about here. Command line packet analysis hints. TShark is a text-based tool and is suitable for data carving, in-depth packet analysis, and automation with scripts. And this strength and flexibility come out of the nature of CLI tools, as the produced/processed data can be pipelined to additional tools. The most common tools used in packet analysis are below. And that's absolutely true. A lot of times with these GUI or graphical user interface tools, they're not as flexible as the command line tools, which is why you should be comfortable in the command line. If you need information on Linux command line, go ahead and search my channel for that. So let's see here: tool utility, and then you have the purpose benefit over here. Cap infos, a program that provides details on a specified captured file. It is suggested to view the summary of the capture file before starting an investigation. See, we already have one in here, so let's just type this in: cap info s and demo. All right. So it pulls up all kinds of information, as we can see here. So let's go ahead and read on. grep, we already know about grep, right? Helps search plain text data. grep is one of the most useful tools that you'll have in your tool belt in the CLI. Cut helps cut parts of lines from a specified data source. You got unique, you got NL, sed, and awk down below. Sample usage of these tools are covered in the Zeek room. Check out my channel for information related to Zeek. Open the terminal, which you already have open. You can follow along with the interactive materials by switching to the following directory, which we are in right now. And also, an easy way to get into this directory, if you don't want to navigate that way, you can just go straight to the folder here, right click it, and then open in terminal. And I'll open it right up inside of there. So let's flip back over to our terminal. Okay, so we've already ran this, and we saw all kinds of information. Question time. Find the task files already done. View the details of the demo.pcapng file with camp infos. What is the ripe MD160 value? Well, we can see it right away. It's right here. So let's just go ahead and grab it real quick and plug it in. So I'm going to right click and copy and paste it over as our answer here. Now we're done. But it has all kinds of useful information here about this particular PCAP file. Task number 3, we're going to talk about the main parameters, part 1. Command line interface and parameters. TShark is a text base, we already know that. Okay, it says multiple built-in options are ready to use to help analysts conduct such investigations. However, learning the parameters is essential. You will need the built-in options and associated parameters to keep control of the output and not be flooded with the detailed output of TShark. The most common parameters are explained in the given table below. Note that TShark requires super user privileges to sniff live traffic and list all available interfaces, which makes sense. And you have parameter and purpose. So -H, display the help page. As with most tools, -H or -- help is going to be the help page of the tool. -V, version information, same thing. -D, list of available sniffing interfaces. So for just following along here, we can do TShark -H, and I didn't put the dash in there, so let's try that again. -H, there we go. And this is -I for interface to capture live traffic. So if you want to capture on interface 1, you put -I, then 1, and then -I, then the name of the interface if you want to capture on a specific named interface there. The no parameter, just sniff the traffic like TCP dump. It's pretty useful. So here's -H here, and it has all the other parameters and such inside of here that you can reference as well. Okay, so if we want to do, let's go ahead and clear the screen, and TShark -V for version, we can see what version we have on this particular box here. See the version up here appears to be 3.2.3 for this. Okay, that's good to know. And it says let's view the version, which we've already done here. Sniffing is one of the essential functionalities of TShark. A computer node can have multiple network interfaces that allow hosts to communicate and sniff the traffic through the network. Specific interfaces might be associated with particular tasks or jobs. Therefore, the ability to choose a sniffing interface helps users decide which and set proper interface sniffing. Let's view the available interfaces on a given VM. Well, you can do that with -D, and that's true. Like you can do that with Wireshark as well. Sniff live traffic on interface. So we have this here, which will probably be using number 1. You have loopback, any, and a bunch of other ones that you can possibly pick here. Sniffing can be done with one or with and without selecting a specific interface. When a particular interface is selected, TShark uses the interface to sniff the traffic. TShark will use the first available interface when no interface is selected, usually listed as 1 in terminal. Having no interface argument is an alias for the -I1. You can also set different sniffing interfaces by using the -I parameter. TShark also echoes the used interface name at the beginning of the sniffing. So that's good to know there. So if we want to do that, we can just do TShark by itself because it'll automatically use 1 from what we just read there. So it's pulling up all kinds of information. All right, so if we just scroll back up a little bit here, that went very quickly. Yeah. So I wonder if we can just pipe that into like more or something. Okay. So now it's a little bit more manageable, and there we go, capturing on that specific interface, which we saw there. Okay, so that's good to know. All right, let's see here. Question time. What is the installed TShark version on the given VM, which we just saw there? So if we do TShark V, we can see that was 3.2.1, or 3, sorry. This is list available interfaces. What is the number of available interfaces in a given VM? Okay, so let's clear all this out. And to get the interfaces again, it was -D. And it says 12 is listed there, so I'm going to go with 12. So there we go. And next task is 4, main parameters part 2. Okay, here's more information about parameters listed in the -H as well when we looked at the help menu. So -R is read input function, read a captured file. So if we want to do that, so let's just clear this out. Then TShark -R, and then demo PCAP. There we go. And then -C, packet count, stop after capturing a specified number of packets, stop after capturing, filtering, reading 10 packets. So you use TShark -C for count, and then the number of packets you want to stop at will be 10. -W, write output a function, write the sniffed traffic to a file. -V, verbose, provide detailed information for each packet. Says similar to Wireshark's packet details pane, interesting. -Q for silent mode, suppress packet outputs on the terminal. And then -X, display packet bytes, show packet details in hex and ASCII dump for each packet. Read packet files, which you've already done here, right? So TShark can also process PCAPs. You can use the -R parameter to process the file and investigate packets. You can limit the number of shown packages -C, okay? And if we want to do that, we already did -R here, right? So let's go ahead and clear this out, and then we can just do the change this R to C and just do 2 like they have on the screen there. And what did I do? You need both of them in there. If I can pay attention. Okay, so we're going to scroll back up to -R. Now we can try it with -C, which makes sense because you're reading it first and then you want to stop at 2. So there we go. Okay, write data. TShark can also write the sniffed or filtered packets to a file, you can save the sniffed traffic to a file using -W. This option helps analysts to separate specific packets from the file/traffic and save them for further analysis. It also allows analysts to share only suspicious packets/scope with higher level investigators. Pretty interesting there. So if we want to do that, of course, -R to read it first, -C one, so they're going to get that first packet, and -W right to demo PCAP. That's interesting. Okay, so we can just try it, follow along here. All right, so we already have that, so let's just change this 2 to 1, and then -W, and then we'll just call it write to demo. Okay, there we go, and it should be there. Awesome. And then now we could do TShark -R to read it. And there we go. Awesome. So let's see here. Show packet bytes, which is that -X parameter. And it does look like what we saw in Wireshark's pane there, right? So if we want to do that with we'll just do the same one. We'll change this to let's see here. Yeah, so we have to do is add the -X at the end of it. So -X. If I can put a space in there. And I accidentally deleted the P, so let's do this. There we go. All right, so once you use this parameter, all packets will be shown in hex ASCII format. Therefore, it might be hard to spot some anomalies at glance. So using this option after reducing the number of packets will be much more efficient. Okay. Verbosity, default TShark packet processing and sniffing operations provide a single line of information and exclude verbosity. The default approach makes it easy to follow the number of packets processed sniffed. However, TShark can also provide verbosity for each packet when introduced or instructed. Verbosity is similar to Wireshark's packet details pane. As verbosity offers a long list of packet details, it is suggested to use the option for specific packets instead of a series of packets. Okay, so this one is like the pane, not the one up here. This one just shows you in like kind of I guess a little bit human readable on the side here. But let's try this one here. So once again, let's clear all this stuff out of here. Okay, I'm just gonna up arrow, and then so they did demo again. All right, so we have similar output as they have there on the screenshot. It's pretty neat to know all kinds of information that you could possibly use in an investigation here. So verbosity provides full packet details and makes it difficult to investigate long and complex terminal output for each packet. However, it is still helpful for in-depth packet analysis and scripting, making TShark stand out. Remember, the best utilization time of verbosity is after you filtered the packets. You can compare the above output with the below screenshot and see the scripting, carving, and correlation opportunities you have, right? So that's what they're talking about here. TShark CLI versus Wireshark GUI, and you can see that the similar output there. Awesome. Okay, and questions here, so go ahead and try to answer them yourself. You should be able to answer them. And if you get stuck or just want to continue on, just come back to the video once you've already at least made a valid effort to try to answer these questions. So go ahead and pause the video, try to answer these questions, come back, and we will continue on. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Okay, let's go and take a look at these questions. Hopefully you're able to answer them yourself. If not, we're going to step through it right now. Read the demo.pcap.ng file with TShark. What are the assigned TCP flags in the 29th packet? So we have tshark-r to read it, and then demo.pcap.ng is going to be the file we're reading, then -c for the count, and then 29 is what we're going to go to. All right, so let's take a look here, and the assigned flags is going to be push and ACK, so we can see right there. Okay. Next one says, what is the ACK value of the 25th packet? So if we take a look at packet 25 here, we can see where when equals 966, or sorry, the ACK value is going to be 12421. Also got the next one where we look at need to find the win value of packet number 9. So we'll scroll up for that one. And that's going to be when equals 9660. So there we go for those. Task number 5, we're going to talk about capture conditions. Capture condition parameters. As a network sniffer and packet analyzer, TShark can be configured to count packets and stop at a specific point or run in a loop structure. The most common parameters are explained below here. So we have parameters and purpose. Define capture conditions for a run or a single run / loop stop after completing the condition, also known as auto stop. With the -a duration, sniff the traffic and stop after X seconds, create a new file and write output to it. So tshark-w to write, and then test.pcap, then -a, and then duration is 1. File size, you can do by file size, stop after X amount of file size, so they have it set to 10 there. And files stop after X files, so stopping after 3 files. File size is 10, then 3 files as well. So ring buffer control options to find capture conditions for multiple runs or loops, infinite loop. So now would be the -v parameter. Duration, sniff the traffic for X seconds, create a new file and write to it. File size, so this is similar to what we just saw in A here from what I can see here. All right, so that's good to know. Capture condition parameters only work in the capture/sniffing mode. And let's see here. Well, B is a little bit different. So it says define, like files, it says define maximum number of output files. Rewrite the first/oldest file after creating X files. So there are slight differences between A and B there, but we can see from what we just read from both of them. But anyway, it says you will receive an error message if you try to read a PCAP file and apply the capture condition parameters. The idea is to save the capture files in specific sizes for different purposes. During live capturing, if you need to extract sorts of packets from a specific capture file, you need to use the read and write options discussed in the previous task. Hence, TShark combining auto stop, which is -a parameters, with the ring buffer control parameters -b. You can combine the parameters according to your needs. Use the infinite loop options carefully. Remember, you must use at least one auto stop parameter to stop the infinite loop. So I wonder what happens if you don't stop it, right? But we don't want to find that out, right? So let's just see if we can just follow along here. And so TShark. All right, so everything's set here. Let's go ahead and run it. Got it. Okay, there we go. We have a couple there listed. Okay, so question time. Pause the video once again, try to answer these questions yourself, then come back and we will continue on. Let's take a look here. Which parameter can help analysts create a continuous capture dump? Remember, they're talking about -a and then -b here. -b is the one we're looking for here. This ring buffer control is the one that we can do. To do that, you can also click the hint, and it'll tell you that here ring buffer controls can help analysts to create queries that can run in an infinite loop. Can we combine auto stop and ring buffer parameters with TShark? Yes, we can, as we just did and read about earlier. We can combine them together. So let's see here. Task number 6, packet filtering options, capture versus display filters. Well, we didn't actually do this, right? We just read about how we could do combine these two right here. I believe in this hint is where it explains that. But anyway, we get the gist of it. So next one we're going to talk about is packet filtering parameters, capture and display filters. There are 2 dimensions of packet filtering in TShark. We have live, post-capture. These 2 dimensions can be filtered with 2 different approaches using a predefined syntax or Berkeley packet filters. TShark supports both, so you can use Wireshark filters and BPF to filter traffic. As mentioned earlier, TShark is a command line version of Wireshark, so we will need to use different filters for capturing and filtering packets. A quick recap from the Wireshark package operation room. And in that room, we learned about capture filters, live filtering options. This purpose is to save only a specific part of the traffic. It is set before capturing traffic and is not changeable during live capture. Then we have display filters, post-capture filtering options. The purpose is to investigate packets by reducing the number of visible packets, which is changeable during the investigation. Capture filters are used to have a specific type of traffic in a capture file rather than having everything. Capture filters have limited filtering features, and the purpose is to implement a scope by range protocol and direction filtering. This might sound like bulk/raw filtering, but it still provides organized capture files with reasonable file size. The display filters investigate the capture files in depth without modifying the packet. What I'm used to doing or dealing with are these display filters in the real world. So I already have like a PCAP file saved, and then I'm just analyzing it via Wireshark with these display filters. Then we have -F here, capture filters, same as BPF syntax and Wireshark's capture filters. -Y, display filters, same as Wireshark's display filters. Check out the Wireshark packet operations room, task form 5, if you want to review the principles of packet filtering, or check out my channel about Wireshark. Another questions here. Okay, so which parameters used to set capture files, and then which parameters used to set display filters? Well, we know -F from up there. We can tell that's used for this one, and then the other one for display filter is going to be -Y. Okay, next task is 7, and then packet filtering options, capture filters. Wireshark's capture filter syntax is used here. The basic syntax capture/BPF filter is shown below. You can read more on capture filter syntax here and here. Boolean operators can also be used in both types. So we have qualifier and detailed and available options. So type, target, match type. You can filter IP addresses, host names, etc. Note you don't set a qualifier. The host qualifier will be used by default. So if host, net, port range, we have a variety of these we can set here. And then filtering a host, TShark-F host, and then at the IP address here, they have a range, and then port range. Direction, target, direction, or flow. Note that if you don't use a direction operator, it will be equal to either and cover both directions. That's cool. So you can set the source, destination, target protocol, self-explanatory, target whatever protocol. You have ARP, Ether, ICMP, etc. there. So this is pretty straightforward so far. Filtering MAC address, Ether host, and then of course the MAC address there that you want to filter on. Okay, this is pretty interesting stuff. We need to create traffic noise to test and simulate capture filters. We will use the terminal instance to have a split screen view in a single terminal. The terminator will help you craft and sniff packets using a single terminal interface. Now run the terminator command and follow the instructions used or using the new terminal instance. First run the given TShark command in terminal 1 to start sniffing traffic. Then run the given curl command in terminal 2 to create the network noise. It says view sniffed packets results in terminal 1. Okay, so I guess we can just go ahead and try this. All right, so we have terminated there. Hit enter. Let's bring up the screen here. Okay, so let's just copy and paste this over. Okay, and copy this over as well. This is capturing. Okay, let's go ahead and paste this over. All right. Okay, that's pretty interesting. And we have the information there. As you can see the GET request and everything there. Cool. Before being comfortable with the command line and TShark filters requires time and patience. You can use the below table to practice TShark capture filters. So if you want to do host filtering, you can use curl to a domain, as shown here, capturing traffic to a specific or traffic to or from a specific host. That's interesting there. And then IP filtering, capture traffic to or from a specific port. We will use the netcat tool to create noise on specific ports. So go ahead and try these yourself as well as we're following along here. All right, Traffic generation with netcat. Here, netcat is instructed to provide details, and timeout is set to 5 seconds. TShark capture filter for specific IP address. Okay, and then with port filtering, capture traffic to or from a specific port. We will use netcat tool to create noise on specific ports, and we can see they create noise on port 4444 there, and then it says timeout set to 5 seconds, and they're capturing on port 4444 with TShark there. You have protocol filtering here, capturing traffic to or from a specific protocol. We will use the netcat tool, and they're looking at UDP here. Okay, that's pretty neat. Question time. Once again, pause the video, try to answer the question yourself, then come back to the video, and we will continue on. What is the number of packets with send bytes? So basically, just go through and you count the number of send packets. So we have 1 and 2, and there's no more inside of here. Okay, so remember, you have to run this tshark-f and then host 10.10.10.10. Okay, so basically just copy and paste what was over here, as we saw in the screenshots earlier. What is the number of packets sent to the IP address 10.10.10.10? So that's going to be our destination. So let's see here. We have 1, 2, 3, 4, 5, 6, and 7 as the last one there. Okay, and then it says, what is the number of packets with ACK bytes? So 1, 2, 3, 4, 5, 6, 7, and 8. There we go. So 8 should be our answer there. Task number 8, packet filtering options, display filters. Now, an easier way to do this is to, when you run this, you can save this as an actual file, as we learned earlier with that -w option, and then you can pipe it into grep. And then with grep, you can filter on like syn or ACK, and then they'll probably be easier to read than just trying to read it like this, like I did. But anyway, task number 8, packet filtering options, display filters. Wireshark's display filter syntax is used here. You can find more about it, this link here. Additionally, you can use Wireshark's built-in display filter expression menu to break down protocols, which we saw in our other Wireshark videos. Note that Boolean operators can also be used in both types of filters. Common filtering options are shown in the given table. Note using single quotes for capture files is recommended to avoid space and bash expansion problems. Once again, you can check the Wireshark pack operations room, task form 5, or check out my video, and you want to review the principles of packet filtering. Okay, so protocol, IP, and then some filtering options would be here. So tshark-y, IP dot addr equals the IP. You have one for network range, source IP with the dot source or SRC, and destination dot DST. So this is very, as I said here, it's pretty much what we're using inside of Wireshark when we had the display filter bar at the top there. TCP, same thing here. Okay, HTTP and DNS. And it says we will use the demo.pcapng file to test display filters. Let's see the filters in action. So let's get out of this here. Close terminals. Okay, let's just clear everything out. And I'm just going to copy and paste this over. Okay. Filtering on this IP address here. The above terminal demonstrates using the IP filtering option. TShark filters the packets and provides output. In a terminal, it is worth noting that TShark doesn't count the total number of filtered packets. It assigns numbers to packets according to the captured time, but only displays the packet that match our filter. That's right. Now with Wireshark, it would tell us this information, the number of display packets. So that's one thing to note there, as stated in this information. Look at the above example. There are 2 matched packets, but the associated numbers don't start with 0 or 1, 13, and 17, are assigned to these filter packets. Keeping track of these numbers and calculating the total number of filter packets can be confusing if your filter retrieves more than a handful of packets. Another example is below here, and they're looking for HTTP traffic here. Okay. Awesome. So you can use the NL for new line command to get a numbered list of our output. I'm pretty sure that's a new line. Therefore, you can easily calculate the total number of filtered packets without needing or being confused with assigned packet numbers. The usage of NL command is shown below. So they're piping that into NL, right? And it looks a lot better than what we saw there. So let's go ahead and clear all this stuff out. Paste this in. There we go. 1, 2, 3, and 4. Awesome. So we have questions again. Go ahead and try to answer these questions yourself. Come back to the video, and then we will continue on. So once again, we're taking a look at the demo.pcapng file. What is the number of packets with this IP address here? This 65.208.228.223. So we can do that with the tshark-r because we're reading that demo pcap file -y because we're using the display filters similar to Wireshark, right? And then IP.addr equals to the IP address in question. And then we're piping it into NL to give us that number of packets, right? Because remember, if we do this by itself, it won't count the number of packets for us by default. You have to put the NL in there. And we can see 34 is what we get back here. So there's our answer for that one. And then our next one is, what's the number of packets with TCP port 3371? Okay, so once again, we're going to pipe things into the NL. So I'm just going to up arrow here. And we can do that with TCP.to-port equals to 3371 because we are looking for TCP port number 3371. Piping that into NL again so we can get that number of packet count. And it's going to be 7, as we can see there. Next one says, what is the number of packets with a 145.254.160.237 IP address as the source address? So let's go ahead and clear this out and up arrow. Okay, and we're looking for the source IP address, so we can do that with IP.src for that display filter option, and then equals to the IP address in question. Once again, we're piping it into NL so we can get that number of packets. Hit enter, and 20 should be our answer there. And the next one says we run the same query again, and then what is the packet number of the duplicate packet? Now for this one, you click the hint here, and it gives you a hint of says duplicate packets are known as TCP/UDP dupe or whatever. So with this one, what I did was piped it into grep with that information, as we'll see here in a second, right? So I'm running the same query again, except I'm piping it into grep, and I'm looking for DUP or duplicate, right? See that information here, and it comes back with packet number 37 is our answer there, and we can see the dupe here on the side. Okay, that's pretty cool stuff here. And conclusion, congrats, you just finished the TShark The Basics room. In this room, we cover TShark, what it does, how it operates, and how to use it to investigate traffic captures. Now I invite you to complete the TShark CLI Wireshark features room to boost your CLI packet hunting skills by implementing Wireshark features with TShark. Before we wrap it up here, remember that there's another website out here that you can utilize called Malware Traffic Analysis if you want more practice on this PCAP information. It's a site for sharing packet capture PCAP files and malware samples. Okay, they have all kinds of stuff in here. It's pretty good. They have over here some tutorials, workshops, so you can click on that. It takes you to that information there. If you want the actual practice exercises, click on this one here for training exercises to analyze PCAP files of network traffic. All right, click here and they have a plethora of different files you can go through, and they want you to start from top to bottom, okay? Because things change over time. But this is just extra homework if you want to learn more about utilizing TShark or Wireshark to analyze PCAPs. So we're going to wrap this up, hit the complete here. And if you enjoyed this video, be sure to like, comment, subscribe with that notification bell so you know every time I post to the channel. All that good stuff helps grow our community here, helps keep the channel growing. And as always, thank you for your time. Thank you for watching. Have a nice day, and I will see you in the next video.